Back when the Electronic Industries Association was founded, having even one electronic gadget at home caused a great deal of excitement.
Traffic accident northbound Long Beach Freeway.
Now, over 60 years later, electronic products have become a necessity rather than a luxury. And as our use of electronics has grown, so has the association. The EIA is the National Trade Association representing manufacturers of the electronic products that we use and enjoy. The EIA informs, educates, and interacts with consumers, manufacturers, and government agencies to keep pace with the rapid growth of the electronics industry.
The information in this video teaches the principles of optical pickup systems found in current consumer electronic products, such as video laserdisc and compact disc players. The service procedures are typical for the examples used in this video. Always follow the listed service procedures and cautions specified in the service literature for the product being serviced. Optical pickup devices were first applied to the video laserdisc player. Generally, today's video laserdisc players play both compact discs and laser discs. Some models include enhanced features for playing karaoke discs and optical pickup systems that sequentially play both sides of a two-sided laser disc. Today's video laser discs incorporate digital audio based on the compact disc format in addition to the FM analog audio. The compact disc format combines the digital and laser technologies, resulting in exceptional audio performance. Compact disc technology continues to grow as innovative products are added to the list of products based on the compact disc format. Such products include CD-ROM, CDI, and Photo CD. Compact disc players are available with multi-disc changers to allow the user to load and program the playback sequence of multiple compact discs. Although the data forms differ, both the video laserdisc and compact disc systems are based on identical optical pickup principles. Basically, a laser beam is used to follow and read the disc's spiral track, which is made of a continuous row of pits. Early video laser disc players used gas lasers in combination with mirrors and lenses to track the discs. Modern players use much smaller and simpler solid-state pickup devices. The pickup device is used in combination with servo circuits to provide focus, tracking, and detection of the data. In addition, a servo is used to control the speed of the motor and data rate. An overview of the disc format should first be considered in order to understand the principles of pickup devices. To begin with, both video laserdisc and compact disc tracks must meet certain specifications to be compatible with existing optical pickup systems. Thus, the track width is typically about 4/10 to 6/10 of a micron, and the track pitch is about 1.6 microns. Looking at the top of the disc, with the optical pickup unit tracking from the bottom, the disc rotates in a clockwise direction. The beginning of the spiral track is located at the inner circumference of the disc. Thus, the tracking direction is from the inner circumference to the outer circumference of the disc. The information on a laser disc is arranged in two ways, CAV and CLV. In the constant angular velocity format, each revolution of the disc contains one frame. In order to display the video information at a standard frame rate of 30 per second, the disc must spin at a constant speed of about 1,800 revolutions per minute, which equates to 1 revolution per frame. Constant angular velocity accommodates special play modes such as still, fast, slow, and strobe. However, playing time is limited to 30 minutes per side. Constant linear velocity, or CLV, is a more efficient method of encoding information on a disc. Twice as many frames can fit on a CLV video laser disc than on a CAV video laser disc. Constant linear velocity provides a longer playing time since the track's linear speed is constant. As the CLV video laser disc is tracked in the outward direction, the disc's rotational speed is reduced. The rotational speed at the inner circumference of the video laser disc is about 1,800 revolutions per minute, whereas only about 600 revolutions per minute at the outer circumference. The linear track on the disc is actually made up of a continuous row of microscopic pits. The length of and space between each pit is a result of the encoding and stamping process. Although the compact disc is an optically read disc, there are some major differences between it and the video laser disc. The data is in digital form and is formatted to provide up to 74 minutes of audio on a 5-inch disc. Only the CLV arrangement is used in the compact disc. Since the track velocity is about 1.3 meters per second, the disc spins at about 500 revolutions per minute at the inner circumference and about 200 revolutions per minute at the outer circumference. At the heart of the modern optical pickup system is the solid-state laser assembly. The laser diode package contains the laser diode that emits the laser beam and a monitor photodiode to monitor the intensity of the laser emission. The simplified circuit illustrates the method used to regulate the laser current. The driver transistor is used to regulate the current to the laser diode. The monitor diode is the feedback device used to regulate the driver transistor's current. The current from the monitor diode is fed to the error amplifier, which proportionally detects the intensity of the laser diode. In some optical pickup systems, a laser output control is included to adjust the laser output to its nominal level. Refer to the manufacturer's service manual to check for adjustments and output levels. Care should be used when handling optical pickup devices. The devices may be damaged by electrostatic discharge if not properly handled. A grounded ESD protected mat with ground strap and grounded equipment must be used when handling ESD sensitive devices. Care should be taken to protect the eyes when servicing any laser device due to the emission of the invisible infrared laser beam. Never look directly into the objective lens with the unit turned on. There are basically two types of optical pickup devices: the 3-beam system and the single-beam system. Optical pickup devices, whether single-beam or 3-beam, are highly complex electromechanical devices that rely on precise mechanical, optical, and electrical principles. The 3-beam optical pickup unit consists of photosensors and a laser diode assembly with lenses and mirrors for shaping and directing the laser beam. The focus servo controls the up and down movement of the objective lens to focus the laser beam onto the reflective surface of the disc. The 3-beam system uses a sled-type tracking system. The tracking servo circuit controls the tracking via the tracking drive coil for fine control of the tracking and via the sled or feed motor for course adjustments. The 3-beam optical pickup unit uses a single laser diode to emit a laser beam. Although there are different optical pickup designs used in three-beam systems, this illustration serves to explain basic three-beam optical pickup principles. The laser beam is diffracted into several beams by the grating element. Only the three center beams are utilized. The center beam, having the greatest intensity, is used for focusing and for data pickup. The less intense second-order subbeams are used for tracking. The half mirror acts as a semi-reflective surface to the three beams coming from the grating element. The laser beams are directed to the objective lens by a mirror. The objective lens is used to focus the beams onto the disc's reflective surface. The photodiode array is composed of 6 photodiodes. The two outer photodiodes, E and F, detect tracking errors, while the other 4 photodiodes, A through D, detect focus errors and pick up the modulated data signal from the spinning disc. The reflected secondary or radial beams used for tracking strike the two outer photodiodes E and F. The difference in intensity between the reflected beams is detected as the tracking error signal. The tracking error signal is used by the tracking and sled servo circuits. The three-beam pickup system is used in both laserdisc and compact disc players. A three-beam servo block diagram for a typical video laserdisc player includes the focus servo, sled or feed servo, tracking servo, spindle servo, and tilt servo. The tilt servo and time base corrector are not required in a three-beam compact disc player. The focus servo for the three-beam optical pickup system uses 4 photodiodes to develop the focus error signal. The optics of the three-beam system provides a focus error detection method known as astigmatic focus detection. The focus error signal is derived by comparing the signals from 2 pairs of photodiodes. The shape of the reflected center beam striking the photodiode array determines the amount and polarity of the focus error. The difference is detected in the focus servo circuit, which outputs the focus drive signal to keep the laser beam focused on the reflective surface of the disc. Focus servo lock is achieved during the focus initialization. Tracking is accomplished via the tracking and sled servos. The tracking error is derived by finding the difference in the signals from photodiodes E and F in the optical pickup unit. These 2 photodiodes pick up the reflected beams from the radial or secondary beams. Ideally, the radial beams strike the reflective surface of the disc adjacent to the row of pits being read by the main beam, and the main beam strikes the center of the pit row. The tracking servo thus attempts to minimize the tracking error current, which is determined by the difference in current between photodiodes E and F. The angle of the secondary beams to the track, known as the grating angle, is very critical. If the grating angle is not adjusted properly, tracking becomes erratic or, in extreme cases, impossible. The grating angle is now set by the factory and is not a service adjustment. In a video laser and compact disc combination player, the type of disc loaded in the player must be detected. During startup, the optical pickup unit is positioned via the sled drive to detect the type of disc loaded in the player. The system first checks for the presence of a video laser disc. If focus is not found, the optical pickup is positioned to detect a compact disc. The gain of the spindle servo and torque of the spindle drive motor is set according to the type of disc detected. For example, higher torque is required for the greater mass and size of a 12-inch video laser disc than for a 5-inch compact disc. The spindle motor starts to rotate according to the type of disc detected. and the sled drive positions the optical pickup to the lead-end tracks. The table of contents located in the lead-end area is read from the disc. At this point, tracking servo lock is achieved. The fine tracking is accomplished via the tracking coil. The low-frequency sled drive is used to control the forward or reverse drive to the sled motor. In normal play, when the tracking coil current reaches a designated level, the sled motor drive momentarily kicks on to step the sled forward. Logic from the microcomputer provides directional control of the tracking servo to advance or reverse the direction of the sled mechanism for track jumping when required. For example, during search forward or reverse. A tilt servo is used in the video laserdisc player to ensure that the laser beam from the pickup is perpendicular to the disc. Normally, the tilt servo is only active for playing the larger video laser discs. A larger disc sags toward its outer perimeter due to its large diameter and weight. The tilt servo adjusts the angle of the tracking laser beam to keep it perpendicular to the reflective surface of the disc for optimal tracking. The tilt servo uses two photodiodes and a light-emitting diode to detect and correct tilt errors as a disc plays. A tilt neutral circuit is used to place the tilt mechanism in its neutral position for the smaller diameter compact disc. As the name implies, the single beam optical pickup unit uses only one laser beam to read the disc data and to achieve focus and tracking. Thus, there is no need for grating. However, there is an element known as a beam splitter that splits the reflected modulated beam in half. The two beams are used to detect focus and tracking errors in the single beam system. Another difference is in the photodiode array. 4 photodiodes pick up the modulated data and detect both tracking and focus errors. The single beam system is used in compact disc systems only. The single beam servo block diagram for a typical CD player includes the focus servo, radial servo, and spindle servo. The optical pickup outputs several signals as a result of reading and tracking a spinning disc, including the high-frequency data signal and the low-frequency radial error and focus error signals. The photodiode signals are applied to AGC amplifiers, followed by low-pass filters. The focus error is found by detecting the difference in the signals between two photodiode pairs. The focus error is derived from the 4 low-frequency photodiode signals. A focus initializing circuit controls the focus startup to initiate focus servo lock. Focus initialization is controlled by the servo microcomputer. The focus drive signal reveals the condition of the focus initializing and the focus error servo signals. The focus drive signal controls the focus movement of the objective lens via the focus coil. Tracking is accomplished via a radial swing arm controlled by a radial servo. The radial swing arm pivots on an axis located outside of the diameter of the disc. Unlike the 3-beam tracking system, which utilizes both tracking and sled servos, the single-beam optical pickup uses only the radial servo to follow the disc's spiral track. The radial error signal is derived from the photodiode currents in the photodiode signal processor stage. The radial error signal processor controls the radial drive signal. Logic provides control of the radial error signal processor to control the radial servo lock and track jumping functions such as track search, fast forward, and reverse. The single-beam radial tracking system requires some gain and phase compensation due to the difference in the angle of tracking as the optical pickup unit tracks across the disc. A wobble signal is injected into the radial servo loop to provide radial servo lock. Without the wobble signal, the radial system does not track properly in the single-beam compact disc system. HF, or high-frequency processing, is virtually the same in both the single-beam and three-beam optical pickup systems. The high-frequency signal is processed by an AGC circuit and data equalizer to provide an equalized data bit stream to the decoding circuits. The equalized high-frequency signal is commonly referred to as the I pattern. The equalized HF I pattern signal is applied to the decoder, where the bit clock is regenerated and the EFM is demodulated. A circuit may also be used to detect the HF signal. The detection circuit detects the loss or reduction of the HF signal, which may be caused by dropouts in the data stream due to dust or damage on the disk's surface. The detection circuit develops logic control signals to indicate the condition of the HF signal. A track loss logic level is used to notify the microcomputer of a track loss condition, which may be due to a severely damaged disk or by severe shock to the player, causing a momentary loss of track. In this case, the servo loop may be momentarily opened while the microcomputer momentarily controls the tracking position of the optical pickup. Each type of optical pickup system requires a control circuit. The control circuit uses a microcomputer to control all functions of the system and acts as an interface between the user and the compact disc unit. For example, the microcomputer controls functions such as open and close tray, play, and other user functions when requested. This system control block diagram is typical for compact disc players. The microcomputer controls and monitors all aspects of the servo system. For example, when a disc is loaded in the player, the microcomputer initiates the disk startup procedure to detect and decode the CD's table of contents. The table of contents in the lead-in area contains information such as the catalog number, total number of tracks, total time, and other information pertinent to the disk that has been detected. After a disk is identified, player functions are enabled. It is important to remember that some faults can be caused by either the system control or by the processing circuits. A determination of whether a condition is caused by either the system control block or by the processing block must be made when troubleshooting a unit. The system control microcomputer generally detects error conditions in the CD processing circuits and controls the unit's functions, such as programming the play sequence of a disk and tray open-close. The compact disc processing functions include focus, tracking, spindle, feed, and decoding. However, these functions are controlled and monitored by the system control block. The condition of the unit and a cause of a particular symptom can be isolated using the diagnostic and test modes and by checking sensor inputs and control outputs between the system control microcomputer and the processing circuits. All video laser disc and compact disc players require a means for controlling the system. Part of the control includes the startup of the disc. Startup is initiated by the microcomputer when the compact disc loading tray is closed with a disc. Although the startup procedure differs from one manufacturer to another, the basic startup principles apply to all systems. First, the laser diode turns on, and the objective lens moves up and down to detect the presence of a disc. In some units, the optical unit is first positioned to seek the rest position, and the spindle motor begins to spin during the focus initiation. Without a disc, the focus search occurs more than one time. If a disc is not detected, an error is indicated by the system and the startup procedure is terminated. With a disc loaded, a good laser will catch the focus on the first pass of the focus search. If the focus search occurs more than one time with a known good disc, the unit may be in need of adjustments or the laser diode may be weak. Shortly after a disc is detected, the spindle motor turns on to rotate the disc, and the control circuit provides drive to position the objective lens to the area of the lead end tracks to retrieve the table of contents. The table of contents, also referred to as the TOC, contains data which identifies the disc and its contents. The TOC is decoded, and its data is sent to the microcomputer. In the case of a CD player, the decoded data is displayed on the CD player's front panel display. Typically, the number of tracks and total playing time are displayed. The unit is now ready for the play mode. In some players, the unit automatically enters play after a disc is loaded and detected. Adjustment procedures vary from one system to another. Some units are digitally adjusted via a computer, and some units are self-adjusting. The service manual of the unit being serviced should be consulted before attempting any adjustments. In most cases, adjustments are necessary only after the replacement of a component. In some cases, the test point for the adjustment procedure may only need to be checked for verification of the correct waveform or signal level. In many cases, these test points can be used when troubleshooting the unit to verify proper performance. Some preliminary checks can be made to determine the actual condition of the unit. For example, if there is a failure in the power supply, the optical pickup system may not function. Also, the system control circuit may be faulty, preventing startup of the optical pickup system. Servo faults can be ruled out if the unit's display indicates elapsing time and track information, although there is no audio output from the DAC and filters. This condition points to a problem in the later stages of the unit, such as the digital to analog converter or analog filters. In the case of a combination player, check the unit with different disc types. The optical pickup system must be working if the unit functions with a compact disc, but not with a video laser disc. This symptom may be caused by a fault in the spindle servo circuit or signal processing circuit. The processing circuits differ according to the type of disc loaded in the video laser disc player. Use the proper diagnostic tools to service the product. There are test discs, jigs, and service aids available for performance and diagnostics. Special test fixtures and discs are listed in the service manual for the model being serviced. Most compact disc and video laserdisc players incorporate test modes. The service literature for the model being serviced outlines the procedure for implementing the test modes. Usually, the test modes can be used to isolate the fault to a specific circuit. In some cases, test modes are required to perform adjustments, especially in the case of video laserdisc players. Typically, tests include methods for checking the laser, focus, tracking, and spindle servos. When the focus test mode is implemented, the optical pickup's laser diode turns on, and the objective lens continuously moves up and down. This test mode allows the focus servo to be tested without the other servo circuits. This mode allows troubleshooting of the laser control and focus startup with and without a disc. The focus signal can be monitored when troubleshooting the focus servo circuit. Here we see the focus drive signal under normal operating parameters. The laser output can also be checked while in this test mode. In test mode 2, the spindle motor turns on and the focus servo is locked. A low from the track loss not signal indicates focus servo lock. If focus is not achieved, as indicated by a high track loss not signal, continue to troubleshoot the focus servo loop. For example, if one of the photodiodes in the photodiode array is defective, focus lock could not be achieved. A low-frequency signal should be present at each input of the photodiode signal processor in order to develop the focus error signal. If the focus test mode passes, the next test mode is implemented, in this case the spindle servo. A properly operating spindle servo circuit indicates much about the condition of the unit. For example, the decoder stage for regenerating the bit clock must be operating. If the spindle servo does not lock, there may be a problem in the decoder stage. The system clock must also be available for the decoder and spindle servo circuits to operate. Knowing the startup procedure is essential in diagnosing a CD player when the symptom is disc does not play. Usually, the first place to look for clues of the fault is the player's display. Most players indicate an error if a disc is not detected. For example, although a disc is placed in this player, the display indicates no disc. Several conditions may cause this symptom. Possible causes of this symptom include no laser output from the optical pickup, no pickup of the modulated beam, no or poor focus, no startup initiation, radial error, preventing positioning of the optical pickup to the lead-in area for reading and detecting the TOC, and failure to read and detect data for processing. Place the CD mechanism into the service position. In some cases, extension cables may be required to position the mechanism for service. An interlock may need to be defeated, or a tray switch may need to be positioned to simulate a closed tray condition to allow the optical pickup to function. After placing the CD mechanism into the service position, look at the objective lens without a disc when the unit is powered. In most players, the control microcomputer initiates startup to check for the presence of a disc. Normally, with no disc loaded, the focus search cycle occurs 2 or more times. Thus, in this instance, the assumption is made that startup is indeed operational. Place the unit in the service mode to turn the laser diode on. In this mode, focus search may occur several times. Even though the focus search is operating, the display indicates an error, that is, no focus servo lock. It may be that either the focus servo is not functioning properly or the laser diode is not turning on. Check the laser output with a laser power meter or other laser detection device. No laser output detected may be caused by a defective laser diode or laser drive circuit fault. The next logical step is to check the laser drive circuit. If the drive voltage is present, the laser diode in the optical pickup is most likely defective. However, make sure that there are no opens in the connectors or flex cables before replacing the optical pickup. A no-play condition is fairly easy to isolate. However, some problems are not quite as easy to find. For example, symptoms such as poor playability and intermittent playability. A poor playability symptom may be that the player does not play a disc all the way to the end, or it may be that startup is intermittent. Skipping is also a symptom of poor playability. Performance test discs are helpful in diagnosing such conditions. For example, a maximum diameter test disc may be used to test playability at various tracking positions. Some test discs allow tracking and error correction performance checks. These discs have known faults, such as scratches and smudges, which can be used to test the unit's ability to correct for such errors. It is also helpful to use the diagnostic modes to troubleshoot such conditions. In addition, use an oscilloscope to check the condition of the signals of the servo circuits. The eye pattern also reveals the condition of the laser pickup device and servo circuits. The eye pattern is an indication of the condition of the pickup system. Jitter and distortion in the eye pattern may indicate a poor tracking condition. A close inspection of the optical pickup system can sometimes reveal a fault. A dirty objective lens reduces the laser output from the objective lens, causing skipping or intermittent play conditions. The lens may be cleaned following the manufacturer's instructions located in the service manual of the unit being serviced. The optical pickup unit and objective lens are sensitive devices. Only service-approved lens cleaning solution should be used with extreme care to prevent damage to the unit. Close inspection of the tracking may reveal a mechanical fault. Placing the unit in the tracking servo test mode may be helpful in locating a mechanical problem. This is especially true in the case of portable units that are likely to be exposed to adverse conditions, such as at the beach. Sand may get into the gears and sled mechanism, causing tracking error conditions. Clean and lubricate the mechanical section as indicated by the service manual for the unit being serviced. Also, carefully moving the tracking mechanism manually may reveal a mechanical fault. Poor playability may also be caused by an error in the angle of the laser beam to the reflective surface of the disc. The problem may be due to a fault in the tilt servo in units with a tilt servo circuit. Implementing the tilt servo test mode may reveal the fault. However, compact disc players generally don't have a tilt servo. In this case, however, there is usually a method for checking and correcting the reading angle of the laser beam. Although a failing laser diode in the optical pickup unit may cause playability problems, good troubleshooting techniques should be used to rule out any other possible faults. An optical pickup may be replaced needlessly if good troubleshooting procedures are not followed. A unit may even appear to function properly after an optical pickup is replaced. This is due to the fact that with a brand new laser diode, which operates at its highest efficiency and brightness level when new, the unit will operate even with less than perfect conditions or with other faults still present. However, after just a little aging on the laser diode, the unit may exhibit the same symptoms that were present prior to replacing the optical pickup. Poor tracking or poor playability may also be caused by a fault in the tracking servo. If poor tracking is the symptom in a single beam compact disc player, check for the wobble signal in the radial servo loop. If it is not present, check the radial servo circuit. In a 3-beam system, performing the tracking servo adjustment test procedures can reveal the location of the fault. After completing repairs, it is a good idea to at least go through the adjustment check procedures to verify the unit's performance. Finally, after completing repairs, Follow the performance and safety test procedures in accordance with the unit's service manual. We hope you've enjoyed this video presentation. Please refer to the accompanying workbook for terms of reference and further information on optical pickup devices. Apart from video training tapes such as this, Product Services also has a series of low-cost training classes and educational materials for the consumer electronics technician and instructor. Write CEMA Product Services, 2500 Wilson Boulevard, Arlington, Virginia, 22201.